Hello and welcome to STAT 441 at Virginia Commonwealth University. In this lecture, we will discuss the uniform distribution. Uniform distribution is a type of a continuous distribution that we have been discussing in chapter 5. So here is the probability distribution or the probability density function of a uniform random variable y. This variable y is called a random variable because the probability of this variable between the values a and b. So the variable y exists between a and b. So y is greater than equal to a and then less than equal to b. The probability density is uniform. It is the same throughout. So basically, the f of y for this function is 1 divided by b minus a between a and b, and it's 0 elsewhere. The mean and variance of this function are a plus b divided by 2, and then sigma square or variance is b minus a squared divided by 12. And this can be calculated using the expected value and sigma square formulas that we saw earlier, but we will use these directly here once we know that we have a uniform distribution. So this is what the uniform density function looks like. This function is true between a and b, and this is constant. The probability here is constant for the values between a and b. So this total area under this rectangle is 1, and this is where the probability is 1 over b minus a. Okay, so here's an example. We can use the probability density function, the mean and variance formulas to calculate the problems here. Okay, suppose the research department of a steel manufacturer believes that one of the company's rolling machines is producing sheets of steel of varying thickness. The thickness y is a uniform random variable with values between 150 and 200 millimeters. Any sheets less than 160 millimeters thick must be scrapped since they are unacceptable to buyers. Okay, so what this means is that this variable y can take values between 150 and 200, and because it's a uniform random variable, the probability density function will be 1 over b minus a, or it will be constant between a and b. So here's what we need to calculate. First, we need the mean and standard deviation of y, the thickness of the sheets produced by this machine. Then we will graph the probability distribution and show the mean on the horizontal axis. We will also show the 1 and 2 standard deviation intervals around the mean. And then finally, we will calculate what fraction of the steel sheets produced will have to be scrapped. So first, the mean and standard deviation. We know A is 150 here and B is 200. So mu or mean is A plus B divided by 2, 150 plus 200 divided by 2, which is 175 millimeters. The standard deviation is B minus A divided by square root of 12, which gives us 14.43 millimeters. Now, because it's a uniform distribution, the f of y can be written as 1 over b minus a, or 1 divided by 200 minus 150, which is a constant. So it's just constant 1 over 50 for this particular example. The mean we calculated is 175, and then sigma is 14.43. Okay, so let's look at what the distribution will look like. The probability density function f of y is 1 over 50. This value of y is from 150 to 200. Okay, and because it's a uniform distribution, it will just look like a rectangle with a height of 1 over 50, and then width here is 200 minus 150. So 50 is the width. We calculated the mean to be 175, and sigma is 14.43. So 175 is the mean. This is the one standard deviation interval, mu minus sigma and mu plus sigma, and this is the two standard deviation interval, which is actually outside these values. Okay. Now, to find the fraction of steel sheets produced which will be scrapped, we know that if the thickness is less than 160, it will be scrapped. So there are a couple of ways we can calculate this. We can use integration, or because we know we saw the shape is a simple rectangle, so we can just calculate it as the area of a rectangle. So probability of y less than 160, the base is from 150 to 160. So those are the values which will be true for less than 160. And the height is 1 over 50. That's 1 over b minus a. And that is 1/5. Okay. So basically, if you look at this, this is 1/5 area. So 1/5 or 20% of the steel sheets made by this machine must be scrapped. Okay, and this is the remaining 80% of the area. Total is 100. So you could use integration for this uniform density. So we would have to integrate 1 over 50 from 150 to 160. Okay, and that will still give you 1/5 as the answer. Or we took a shortcut here because we know it's a rectangle. So, and we know the height is 1 over 50 and this width is 10. So we just calculated the area of this rectangle. So either way is fine. So uniform distribution, it's a pretty simple distribution in terms of calculation, but it is a useful distribution because we do come across real life situations where the probability of a range of values existing is uniform or is a constant. Okay, thanks for watching. In the next video, we will discuss the normal distribution.